Hey guys, today we're going to learn about family of functions. So today's I can statement says, I can relate all linear functions to the linear parent function f of x equals x. A family of functions is a group of functions that have the same basic characteristics in common. Graphs of the same family are transformations of the parent function, which is the most basic function with the defining characteristic for the family. The parent function for the linear family is y equals x. And the general form for that linear family is y equals mx plus b. That's the formula that you all have memorized. Remember that the graph of all linear functions is a straight line. That root word is of linear is line, so that could clue you in. Y equals x looks like this. Okay? So that's what we're going to compare everything to. So as we do that, let's look at this equation, y equals x, to determine the slope and the y-intercept for this function. The slope, remember, in front of the x is an understood 1. So I know the slope has a 1. The y-intercept, there isn't one, so that placeholder could be a 0 or is a 0. You could rewrite this parent function as y equals 1x plus 0, and it would give you the exact same thing. All right, so when looking at linear graphs that are transformations of the parent function, look at the three following characteristics. The first one is the direction. When you're talking about the direction, you're talking about the slope. The slope, it determines whether the line has changed directions, whether it's going uphill like this or going downhill like that. And the thing, when you look at the direction, it's talking about the slope. So if I have this graph, f of x equals x, which is the parent function, and I compare it to the function of g of x equals negative x, notice that the direction changed. What did you notice about what the slope is? On the parent function, the slope is a 1. On the g of x function, if the slope is a negative 1. And so what happens is anytime you have that negative, it ends up making it an exact reflection across the x-axis. So like I said, anytime it goes from a positive to a negative, you're talking about a reflection across the x-axis. The next thing that we're going to talk about is is the steepness of the line. Again, the steepness of the line, you're still talking about the slope. It's going to determine whether it's a vertical stretch. So that means it's more vertical. It's more like straight up and down. Or it's less vertical, so it's flatter, a vertical compression. So if you graph the parent function, f of x equals x, like I've done here, and then graph 3x, g of x equals 3x, and then graph h of x equals 1/4 x. When looking at all of these graphs, we have the red graph, that's the parent graph. We have the blue graph, that's g of x. And then we have the h of x, the green graph. Now the question says, which function, g or h, so you're talking blue or green, represents a vertical compression? Compression means it's getting flatter. If I'm compressing something, if I'm compressing this Post-it note right here, it's in a ball. If I compress it like that, I just made it flatter. Okay? So that is a vertical compression. So if it's a fraction, it's flatter. So F and F, that kind of works together. We know that it's a fraction. A vertical compression means it's going to be a bigger number and bigger than 1. So that makes it more steep. And that's what this picture is actually showing you. So this one is 1/4, it's flatter. This one is 3, and it's more steep than compared to this f of x equals x. So the one that's more compressed is h of x. And how we're going to write that is h of x is a vertical compression by a factor of, and that factor means multiply. So we got to figure out what it's multiplying by. 1/4 is multiplying by x, so it's a factor of 1/4. If it was a vertical stretch, you would have said it's a vertical stretch by a factor of, and in this one would have been a 3. Next is the y-intercept. You're talking about the b part on this in this case. You're going to determine whether the y-intercept has changed. Did it move up or down on the graph? In order to figure that out, let's go back to our parent function again. All right, the parent function is right here. It's crossing the y-axis at 0. When I type in g of x equals x plus 2, watch what happens. It's taking that parent function, and all it's doing is it's moving it up the graph. Notice they have the exact same slope, they're parallel lines, but it just moved up 2 units. If I do h of x, which is x minus 5, notice it's moving downward. So it's moving down 5 units. So what transformation occurred from f of x to g of x? We just talked about that. From red to blue, it moves up 2 units. And instead of saying moves, we're going to use the word translation. It's a translation or a slide. It's moving and it's sliding up. And in this case, it was 2 units. And where that 2 comes from is from this y-axis, or y-intercept, I'm sorry. So the next question says is what's the transformation occurred from f of x to h of x? So going from the red to the green. Well, they're parallel, so you know the slope didn't change. All it did was slide down 5 units. And again, that 5 comes from the y-intercept. So you're going to say it's a translation. You could also say slide. Those words are used interchangeably. Down, that's showing you that it's going to be a minus sign. 5 units. All right, example number 1. It says, which equation represents a vertical stretch by a factor of 2? So remember, if it's a vertical stretch, you're talking about the slope. And it's telling you what that slope is. It says it's 2. And a translation of up means plus 5 units. And translation, remember, is the y-intercept. So if we look at our parent function, which is f of x equals x, we know we have to multiply it by 2 for the slope. So 2 times x. When I look at my slope on all of these, all of them, the slope here is 2, but these two are 5, so I know it can't be these two. Now I got a 50-50 shot. If it's going up, it's adding 5, so it has to be C. This one would have moved down the graph. All right, example number 2. Which equation represents the vertical compression? Again, you're talking about the slope by a factor of 1/3. So I know my slope is 1/3. It's getting flatter because it's a fraction. They both have an F. So I know my M has to be 1/3. And so as I look at my M's, this one's 1/3. This one's -7. This is -1. And this is -1/3. So I know it cannot be B and it cannot be C because I know my slope has to be compressed by 1/3. A reflection across the x-axis, all that says is that the slope is negative. Now, when I look at my two options here, I have one positive and one is negative. So I know it cannot be this one. So process of elimination says it's D, but let's continue to look at it. It says, and it has a translation of down. Down means a minus sign of 7 units. So that's where that -7 comes from. Go ahead and turn your page. Now we're going to go the other direction. We're going to look at a graph and then compare that parent function, which I'm going to highlight pink. My parent function is, again, y equals x, or f of x equals x. And I'm going to look and see, I'm going to describe in words what is going on from the f of x to the g of x. So going from pink to green. There's 3 things that I need to remember to look at. One of them is the direction, One of them is the steepness, and one of them is the y-intercept. So remember, direction deals with your slope, steepness deals with your slope, and y-intercept is your b value. So let's look at this. Are these lines parallel is what you should think to yourself. They are, so that means the slope did not change. Let's look at the y-intercept then. It starts off with 0, and then it's moved to 4. So what we are going to write then is it's translating because it's going up. The word for up, you're just going to say up, translating up however many units. So translating up, and it's going up 1, 2, 3, 4 units. All right, let's just talk about 4, 5, and 6 on using the words for the descriptions, and then we'll write the rules. So this one, going from pink to green, there's a couple of things going on here. And the first thing that I notice immediately is that it's flipped. Instead of it going uphill, it's now going downhill. And remember, when it's flipping, it's a reflection across the x-axis. And if you remember from the front page, when it's a reflection across the x-axis, that means our slope has to be negative. So looking at this, I'm just going to make a little note to myself. M is negative. All right, the next thing that I see is on this one, my slope is 1. But I think that when it flipped, it's more steep than what this one was. So I'm going to check out my slope on here. And I need to find 2 points where it crosses perfectly. And I can see, like on my end, it looks a lot easier to see. But right here is another point where it's crossing perfectly. So if I'm rising, that means I'm going down 3 and over 1. So my slope then has changed, and now it's negative. So it's a negative 3 over 1 for the green. That reduces down to negative 3. That really makes sense because the negative is the reflection across the x-axis. And then the 3, we need to determine what is that 3. Since it's bigger than 1 and it's not a fraction, like this is still reduces down to the negative 3. It's not a fraction. That means it's a vertical stretch. It's more vertical. So I'm going to say it's a vertical stretch. And then don't forget, when you're doing vertical stretch or vertical compression, you have to say by a factor of, and then whatever your slope was, it's 3. I know my slope is negative, but these words up here already took care of the negative. That's all that's different because then my y-intercept is the same. So nothing else to look at. All right, looking at number 5, going from my pink line to my green line. I noticed pretty quick that it has moved up, right? It's moved up 2 units. And so my y-intercept has changed. The words when you're looking at that front page of your notes, when you're talking about y-intercept, you're talking about translations. And then you have to decide, is it up or is it down? So this one, moving from the pink to the green, it's definitely going up. So I'm going to say it's translating. It's a translation up. And then how many units? It's up 2 units. I also see that it's not nearly as steep, so it's flattening out. That means the slope has changed. So I need to find the slope. I know the slope of the pink line is 1. When I find the slope of this line, I know that these 2 points cross perfectly. I'm going up 1 and then over 3. So I know, since it's a fraction, my slope is 1/3. It's a vertical compression because it's getting flatter. And then you always put by a factor of whatever your slope is, 1/3. They're both still going uphill, so I don't have to worry about the negative part. Now to talk about the rules of all three of them. Now that we have them all used words in describing what has happened, we are going to write the rule of for g of x in terms of f of x. What those directions mean is we're going to start it out g of x. That's the new function. And then we're going to, whatever it's happening to the f of x, we're going to change it up a little bit. So it said it was translating up 4 units. That's my y-intercept. So I'm going to write f of x and then plus, because up is plus, 4. Again, it's whatever is happening to my parent graph, and then I'm just adding 4 to it. So that's just bringing it up. That's all I have to write there. On my rule for number 4, again, I'm starting out with g of x. And this time, it's affecting my slope, but not my y-intercept. So I know my slope is negative, and it's a vertical stretch of 3. So it's a negative 3, which is where my slope is, and it's going to be multiplied by the f of x. That's all you have to write. F of x is equal to x, so it makes sense that negative 3 times x is what this line is. The last one here, we start with g of x, because that's what the line is titled here, g of x. And it's dealing with changes in the slope and the y-intercept. So 1/3 is being multiplied by the x. Remember, f of x represents x. And then it's translating up 2. So I'm going to do plus 2. Up means to add. If it was going down, I would have done minus 2, but it's not. All right, example number 6. It's the last big section. Each one of these sections on our notes is representative of a section on your homework. So looking at this, you're talking about the parent graph of f of x equals x. Again, just like above, I'm going to highlight that in pink so we can talk about it a little bit easier. And then g of x, I'm going to put in green so it just really stands out on the video. Okay. Now these rules through here are very similar to the rules that we just did up here at the top. All right. So this 3, it's affecting the slope, but it's still going to go the same direction because there's not a negative sign. And this is affecting the y-intercept, and it's going to be shifting it up because it's a plus sign. Number 2 is affecting the slope. Again, it's a vertical stretch because it's a 2. It's bigger than 1. And this is affecting my b value, and that means it's shifting up. So let's compare these two here. The easiest thing, I think, when looking at these is to look at the y-intercept. We're looking for something with a y-intercept of 2 on the green line. If I look at this one, I know immediately my b is negative 3. On here, my b is positive 3. On this one, my b is 2. Here, my b is 3. And down here, my b is negative 2. So just looking at my b value of a positive 2, there's only one possible answer. And just double checking it, the 3, compared from the pink to the green, it is more steep. So C would be a good choice. Number 2 says it's a value of B is 3. So I've got letter B and another B equals 3 at letter D. If you look at these two, using some process of elimination, these two are going the same direction. They're both going uphill. Where letter B here, one is going uphill, the other one is going downhill. When it switches direction, it's affecting your slope. So your slope has to be negative. We have a positive 2, so D has to be my answer. Now, the next one, G3 of x, the reason why that 3 is there is just because it's the third function. And what you're going to do is 1/2 it's making it flatter, and you're looking for a y-intercept of -3. I only have one of those, so that has to be A. And notice going from the pink to the green, it is getting flatter. Number 4, it doesn't have anything happening to the slope, so that means the lines are going to be parallel. But it is shifting down to a -2. So the only one that's at a B of -2 is this letter E. And notice that they are parallel lines. And the last one, it does have a negative slope. It's a 1/2. It does make it flatter. It's not as steep, so it's a vertical compression. And it is at a B of 3. So we looked at that. That's what makes it B. I hope today that you can successfully say that you can relate all linear functions to the linear parent function of f of x equals x. If you keep your notes out and you work on your homework, I'm sure that you'll be able to see a success.